Alright, so on to the next couple problems. For problems 3 and 4, I am also doing something similar. So in problem number 3, I'm going to give you an example looking something similar to number 3. I came up with x squared minus 100 over 4x times 2x over x plus 10. From last week, you have some factoring to do, and most of these problems, when you're given like number 1, number 2, now number 3 and number 4 that I'm going to give you as an example, you do need to do factoring. So I only factor when there's an exponent of 2 with the terms. So this one on the upper left does get factored. 4x, no. 2x, no. X plus 10, no. So the only thing I have to worry about is x squared minus 100. Now this is very similar to example 2 I just did, where you have the difference, subtracting, of squares. These are perfect squares, which means I make two parentheses, put x and x. I want the same number to multiply to 100, so 10 and 10. But to make it negative, when I multiply, I need one positive and one negative. So I factor the top, 4x on the bottom, times 2x over x plus 10. If you like, if it helps you, you can keep the bottom one in parentheses so you know that stays together. Now, as we did on example 1 and 2, if there's something in parentheses, the exact same thing, pluses, variables, numbers, the exact same thing, it can cancel out. So even if they are in two different fractions, one's on top and one's on bottom, they're the exact same thing, so they cancel each other out. So x plus 10 is over here on top, and x plus 10 is over here on bottom. They cancel each other out. X minus 10, that stays together, but there's nothing to cancel it out with. So right now, I have x minus 10 times 2x. So I'm going to write it as 2x, then times x minus 10. I'm just writing what's left. And then on the bottom, for both these things, the only thing I have left is 4x. Writing it like this does help me to understand and visually see I cannot cancel anything with x minus 10, so that's stuck there. But I have the other terms, top and bottom, of 2x and 4x. Well, there's no adding or subtracting, so I have x over x, which does cancel each other out, so those two go away. Now, you just go to simplifying fractions. 2 over 4 will reduce it. So 2/4, if I reduce, I divide each one by 2. I get 1 on top and 2 on the bottom. So 2/4 reduces to 1/2. 1's on top, 2's on the bottom, and I'm left with x minus 10. If you don't want to put the 1 on top, that's fine. I can put x minus 10 over 2. Either way, totally fine. So use that and try example number 3. For example number 4, whenever you see a division sign with fractions, I'm going to take this. Again, this is a similar problem, not the exact same thing, so don't get confused that I'm setting you up to do the same problem. 5 n plus 2 over 21n. Alright, the first thing to be aware of, there's a plus sign here, so I cannot split these up. I could keep them together in a parentheses if that's more comfortable for you. You can put parentheses around that. Now, to make things easier and to make it more like a multiplying problem, I don't want to do division. That's a lot longer. So what happens is I keep the first fraction exactly like it is. If you want to put parentheses around the top, that's fine. What you do is you do the reciprocal of the second fraction. In other words, you flip it upside down. So I'm going to take it and change the division to multiplying. And when I do that, I have to flip-flop this fraction. So I do 21n over 5 and n plus 2. Now, I have this type of problem. I can't do much simplifying yet. So what I'm going to do is do some factoring. Now, I did say, factoring is for exponents of 2, and that is generally the case. However, in this problem, there's a GCF that you can do. Okay. The factoring, I'm sorry, that I meant is doing the double parentheses where you have to do that sort of thing. GCF you can always look for in multiple terms. So in this one, the GCF is 5. There's not a variable in both terms, so I'm going to take this one out to be 5. I have a 5 coming out, and I have 10 divided by 5 is 2. 5 divided by 5 is 1, and I have n over 7 times 21n over 5 and n plus 2. Okay, now let's look at it. The parentheses, 2 plus 1n, that is the exact same thing as 1n plus 2. I could put a 1 here. The 2 is positive here, 2 is positive here. 1 is positive here, and 1n is positive there. So even if they are switched, as long as the positive negative signs hold true, they're the same, then I can cancel those out. One's on top, one's on bottom. The other thing I have is that I have a 5 on top and bottom. Well, that gets to cancel out too. So now what I'm left with only on top is 21n over 7. Well, n is not going to cancel out. There's no pairs, no anything to cancel that one out. So n is going to be left on top. So now I got to take care of my numbers. 21 and 7. Well, this is a division sign, so 21 divided by 7 is 3. And it goes on top because that's where the 21 is. That's where the bigger number is. If you want to write as a fraction, you can put a 1 down there. It's 3 over 1, which is the exact same thing as 3. Your problem may have a little bit more left over, so don't get concerned that you're doing it wrong.